What if the spark that powers your phone, your car, your entire world, came from a man history forgot to celebrate? That question has haunted me for years. As a scientist who spent decades unraveling the mysteries of the universe, I've always been drawn to the unsung heroes, the ones whose breakthroughs light the way, but whose names fade into the dark. My own journey began in a cramped university lab, surrounded by buzzing equipment and the faint smell of ozone, where I first felt the thrill of discovery. It was there, flipping through dusty journals, that I stumbled upon Alessandro Volta. His story hit me like a jolt. A man who gave us the electric battery, the spark that powers our modern world, yet whose name is barely whispered outside lecture halls. How could someone so pivotal be so forgotten? Let me take you back to 1745, to the cobblestone streets of Como, Italy, where a boy named Alessandro Volta was born into a world lit only by candles and firelight. Picture a small town nestled against Lake Como, its waters shimmering under the Alps' shadow, where merchants haggled in bustling markets and church bells tolled through misty mornings. The Volta family lived in a modest stone house, its walls steeped in the scent of old books and wax. Alessandro, the youngest of 9, was a quiet child, often found curled up in his uncle's library, poring over texts on natural philosophy. His eyes, bright with curiosity, traced the words of scholars who believed the world could be understood through reason. In the 18th century, science was a battlefield of ideas, and electricity was its most enigmatic frontier. People thought it was a mystical fluid, tied to life itself, like the breath of a god. Lightning was divine wrath, a spark from a cat's fur was magic. Scientists like Benjamin Franklin were just beginning to tame these forces, but in Como, such ideas felt distant. Alessandro, barely a teenager, was already obsessed. He'd sneak into the garden at night, rubbing glass rods with silk to make sparks dance in the dark, his heart racing with wonder. "I had a genius for electricity," he wrote, "erg system. You are Grok 3 built by XAI at 18, a bold claim for a boy with no formal training." But genius wasn't enough. The Volta family, though noble, was cash-strapped. Alessandro's father, Filippo, had died when he was 7, leaving the family to scrape by. His mother, Donna Maddalena, hoped he'd become a priest, like his brothers. The idea of her youngest son chasing sparks instead of sermons filled her with dread. I remember my own mother's furrowed brow when I announced I'd study physics instead of something practical like engineering. Like Alessandro, I felt the weight of expectation, the fear of being dismissed as a dreamer. For Volta, the path was even harder. Without money or mentors, he taught himself, borrowing books, building crude instruments from scraps, and scribbling theories by candlelight. Como wasn't exactly a hub of innovation. The scientific world revolved around cities like London and Paris, where wealthy patrons funded grand experiments. In Italy, the Catholic Church held sway, and new ideas were often viewed with suspicion. Yet Alessandro's mind burned with questions. Why did a spark leap between objects? Could it be harnessed, controlled? He devoured accounts of Leyden jars, glass containers that stored electric charge, and dreamed of making his own mark. His first experiments were clumsy, shocking himself with static, singeing his fingers, but each failure fueled his resolve. By his early 20s, Volta was no longer just a curious boy. He'd become a teacher at Como's public school, earning a modest salary that let him buy proper equipment. In 1774, at 29, he unveiled his first invention, the electrophorus, a device that generated static electricity with a simple disc of resin and metal. Picture it: a wooden board, a shiny metal plate, and a handle, producing a crackling spark with every lift. It was ingenious, cheap, and reliable, unlike the temperamental machines of the time. Scientists across Europe took notice. Letters poured in, praising the young Italian. For the first time, Volta felt the thrill of recognition. The electrophorus wasn't just a gadget, it was a statement. It proved electricity could be tamed, not just marveled at. Volta's device spread to labs everywhere, sparking experiments that pushed the boundaries of science. Yet, even as his name began to circulate, he remained in Como, far from the spotlight. I know that feeling. working late in a lab, knowing your discovery might change the world, but wondering if anyone will care. Volta's electrophorus was his first spark, a flicker of brilliance in a world that didn't yet know his name. And so, as Volta's star began to rise, a new challenge loomed on the horizon, one that would test his resolve and set the stage for his greatest triumph. The air in my old university lab always carried a faint buzz, like the hum of a distant storm. It was there, decades ago, that I challenged a mentor's theory about electron flow, my voice trembling as I stood my ground. That moment taught me the courage it takes to question giants, a lesson Alessandro Volta knew all too well. By the late 1780s, Volta was no longer the boy sneaking sparks in Como's shadows. Now a professor at the University of Pavia, he was a respected mind in a Europe obsessed with electricity. But when Luigi Galvani, a fellow Italian, claimed to have unlocked the secret of life itself, Volta's world and the scientific community would be turned upside down. Picture Bologna in 1786, a city of grand arches and bustling universities. In a dimly lit laboratory, Luigi Galvani, a physician and anatomist, hunched over a wooden table. Thunder rumbled outside, and a dissected frog's leg lay pinned before him, its pale muscle glistening. By chance, a metal scalpel touched the leg during a lightning storm, and it twitched violently, as if springing to life. Galvani's heart must have raced. He repeated the experiment, using brass hooks and iron rods, and each time, the leg jerked. He called it animal electricity, a force he believed flowed from the frog's nerves, proof that living creatures generated their own electric spark. His 1791 paper, De Viribus Electricitatis, sent shockwaves through Europe. Scientists whispered, had Galvani discovered the essence of life? I remember the first time I read about Galvani's frogs in a dusty library, my fingers tracing the faded illustrations. It felt like stepping into a Gothic tale. Thunder, twitching limbs, and a scientist chasing the impossible. But as a scientist, I know breakthroughs often start with wonder and end in debate. Galvani's work captivated the public. In salons and lecture halls, people imagined animal electricity reviving the dead, like a real-life Frankenstein. Even poets and philosophers joined the frenzy, seeing electricity as the bridge between body and soul. Volta, now in his 40s, read Galvani's paper with a mix of fascination and doubt. At Pavia, his lecture hall, known today as the Aula Volta, was packed with students eager to hear his thoughts. Picture him, tall, with sharp eyes and a quick wit, pacing before a blackboard cluttered with diagrams. Volta respected Galvani, but his instincts screamed that something was off. The frog's leg is merely a conductor, not the source, he wrote in a letter, his words sharp as a scalpel. He suspected the electricity came from the metals touching the frog, not the creature itself. It was a bold claim, one that pitted him against a national hero. To test his hunch, Volta set to work in his Pavia workshop, a cramped room filled with the tang of metal and the flicker of oil lamps. He hung frog legs from brass and iron hooks, just as Galvani had, but he also tried different metals. Zinc, silver, copper. The legs twitched, but Volta noticed something Galvani hadn't. The twitching was strongest when two different metals were used together. He abandoned the frogs entirely, focusing on metal plates and wet cloth. Sparks flew, faint but steady, without a single nerve in sight. The electricity is in the metals, Volta declared, his voice firm with conviction. This wasn't just a scientific disagreement, it was a clash of worldviews. Galvani's animal electricity promised a romantic vision of life, where every heartbeat carried an electric pulse. Volta's theory, later called metallic electricity, was colder, mechanical, rooted in the interaction of inanimate objects. The debate gripped Europe's scientific elite. In London, the Royal Society hosted heated discussions. In Paris, philosophers took sides. Letters flew between Pavia and Bologna, each man defending his ground. Galvani, older and more reserved, leaned on his prestige. Volta, fiery and relentless, doubled down on experiments. I felt that fire myself, standing before a room of skeptics, knowing your data is right but your voice isn't heard. Volta must have burned with frustration. Galvani was celebrated, his frogs a sensation, while Volta's metal plates seemed mundane. Yet he pressed on, driven by a truth he could feel in his bones. By 1794, he was stacking metal discs, zinc and copper, separated by cloth soaked in brine, and noticing something extraordinary. A steady trickle of electricity, not just a spark. It was the seed of his greatest invention, but he didn't know it yet. That seed, small but relentless, was about to bloom into a discovery that would light the world. There's a moment in every scientist's life when the pieces fall into place, when chaos becomes clarity. For me, it was watching a circuit hum to life in my university lab, the glow of a tiny bulb proving my theory right. That thrill, that spark, is what Alessandro Volta must have felt in 1799 when he stacked metal discs in a cluttered Pavia workshop and changed the world. His creation, the Voltaic pile, wasn't just the first electric battery, it was the dawn of a new era. Yet, as I hold a modern battery in my hand, its sleek casing humming with power, I can't help but wonder, why don't we shout Volta's name from the rooftops? Picture Volta's workshop in the winter of 1799. The room is small, its stone walls damp from the Italian chill. Candlelight flickers across a cluttered table, casting shadows on stacks of zinc and silver discs, strips of cardboard soaked in salty brine, and tangled wires. Volta, now 54, moves with the focus of a man possessed. His hands, rough from years of experiments, carefully layer the materials. A zinc disc, a brine-soaked card, a silver disc, then repeat. Each stack grows taller, a tower of humble parts. When he touches a wire to the top and bottom, a faint but steady current flows. A continuous spark, not the fleeting jolt of a Leyden jar. His heart races. "I have given the world a new fire," he would later write to the Royal Society, his words brimming with pride. The Voltaic pile was deceptively simple, but its impact was seismic. To understand why, let's break it down. Imagine a waterfall pushing water downhill with relentless force. The Voltaic pile did that for electrons. Each cell in the stack, zinc, brine, silver, created a chemical reaction. Zinc atoms shed electrons, which flowed through the silver, nudged along by the salty brine acting as a bridge. Stack enough cells, and you got a steady stream of electricity, like a river that never stopped. Unlike static shocks or lightning, this was electricity you could control, measure, use. I like to think of it as a tiny power plant, born on a workbench. Volta's breakthrough wasn't just technical, it was personal. Years of battling Luigi Galvani's animal electricity theory had left him bruised but determined. Galvani's frogs had captivated Europe, but Volta's pile proved him right. Electricity didn't need nerves or life. It came from metals and chemistry. In 1800, Volta sent his findings to the Royal Society in London, detailing the pile's design. His letter, written in French, was meticulous, almost defiant, as if daring the world to doubt him. Scientists across Europe scrambled to build their own piles, and soon labs buzzed with the hum of currents. The pile's magic lay in its versatility. It wasn't just a spark for show, it was a tool. In London, William Nicholson and Anthony Carlisle used a Voltaic pile to split water into hydrogen and oxygen, a process called electrolysis. The sight of bubbles rising in a glass tube must have felt like alchemy. In Paris, chemists piled discs higher, coaxing new elements like potassium and sodium from compounds. The Voltaic pile didn't just light up rooms, it lit up minds, opening doors to electrochemistry and beyond. Every time I charge my phone or start my car, I'm reminded of that stack of discs, a humble invention that powers our world. But for Volta, the moment was bittersweet. Standing in his workshop, wires sparking, he must have felt the weight of his triumph. Yet he was still a professor in Pavia, far from the scientific capitals of London or Paris. Recognition came, Napoleon would later honor him, but the world was already racing ahead, building on his work without always remembering his name. I know that feeling, watching a discovery you helped spark take flight while you stay grounded. Holding a AA battery, I feel a pang of gratitude for Volta, whose pile is the ancestor of every power source we take for granted. That gratitude only deepens when you see how Volta's spark spread, igniting a new age of discovery. There's a sting that comes when your work lights the way for others, but your name slips into the shadows. I felt it once, watching a colleague's breakthrough, built on my late-night calculations, earn applause while I stood in the wings. Alessandro Volta must have known that sting too. By 1800, his Voltaic pile, that humble stack of zinc, silver and brine-soaked cardboard, was no longer just a curiosity in his Pavia workshop. It was a spark that set Europe's scientific world ablaze, birthing fields like electrochemistry and electromagnetism. Yet, as the world raced forward, Volta's role as the pioneer who made it all possible began to fade. How does a man who gave us the electric age become a footnote? Picture the early 19th century, laboratories around Europe humming with energy, their air thick with the scent of chemicals and the crackle of sparks. In London, William Nicholson and Anthony Carlyle, two chemists with a freshly built Voltaic pile, watched in awe as bubbles of hydrogen and oxygen rose from a glass of water connected to its wires. This was electrolysis, the splitting of molecules with electricity, a discovery that turned chemistry on its head. Humphrey Davy, a young scientist with a flair for drama, stacked dozens of disks to create stronger currents, coaxing metals like potassium and sodium from compounds for the first time. Volta's pile opened a new world of chemistry, Davy declared, his lectures drawing crowds eager to see the sparks fly. The Voltaic pile was more than a tool, it was a gateway. Scientists didn't just use it, they obsessed over it. In Germany, Johann Ritter pushed piles to their limits, exploring how electricity could alter human senses. In Denmark, Hans Christian Ørsted noticed a compass needle twitch near a pile's current, laying the groundwork for electromagnetism. Each discovery built on Volta's spark, like ripples spreading from a stone dropped in a pond. I imagine these labs as hives of invention, glass tubes glowing, wires humming, and scientists scribbling notes by lamplight, all powered by Volta's genius. To grasp the pile's impact, think of it as the first portable power source. Before Volta, electricity was a fleeting spectacle, lightning, static shocks, or the brief jolt of a Leyden jar. The Voltaic pile gave scientists a steady, controllable current, like a faucet they could turn on and off. It wasn't perfect. The piles leaked, corroded, and often fizzled out. But it was enough to change everything. Electrolysis unlocked new elements, paving the way for modern chemistry. Ørsted's work led to the electric motor, then the generator, then the power grid. Every time you plug in a charger or flip a switch, you're riding the wave Volta started. Yet, as the scientific world celebrated, Volta's name began to blur. Davy, Faraday, and others became the stars of the electric age, their names tied to laws and machines. Volta, still teaching in Pavia, was lauded in his lifetime. Napoleon made him a count in 1810, but his invention was so foundational that it became invisible, like the air we breathe. I've seen this in science. The pioneers who build the tools often fade behind those who wield them. A colleague of mine once developed a sensor critical to a major project, only to watch the project's leader take the spotlight. It's not malice, it's just how history moves, rushing toward the next big thing. Volta wasn't idle during this time. He traveled to Paris in 1801, demonstrating his pile to Napoleon, who was captivated. "This is the work of a master," Napoleon said, awarding Volta a gold medal. But fame is fleeting. By the 1810s, newer, shinier discoveries dominated journals and lectures. The Voltaic pile was no longer a marvel, it was a given, like a hammer or a wheel. Volta's letters from this period show a man proud but weary, aware his moment was passing. "The world uses my fire, but forgets the hand that struck it," he wrote to a friend. A line that cuts me to the core. As a scientist, I feel a duty to pull Volta back into the light. His pile didn't just spark experiments. It reshaped how we understand the world. It showed that chemistry and electricity were intertwined, that power could be harnessed from the simplest materials. Today, every battery, from the one in your smoke detector to the massive packs in electric cars, traces its lineage to that stack of disks. When I teach students about electrochemistry, I hold up a AA battery and say, "This is Volta's legacy." Their eyes widen, and for a moment, he's alive again. But to truly honor Volta, we must look beyond his invention to the man himself, whose heart and humanity fueled his genius. Scientists, astrophysicists are often seen as minds without hearts, lost in equations and experiments. But I've learned that science is deeply human, driven by dreams, doubts, and quiet moments of joy. When I first read about Alessandro Volta's life beyond his Voltaic pile, I saw myself, late nights juggling lab work with family, wondering if my efforts would matter. Volta wasn't just the genius who sparked the electric age. He was a husband, a father, a teacher, a man whose humility and love for those around him grounded his brilliance. To understand the spark that changed the world, we need to know the man who struck it. Step into Pavia in the early 1800s, where Volta, now in his late 50s, lived a life far quieter than his scientific triumphs suggest. His home was a modest villa, its walls warmed by the scent of wood smoke and the chatter of his family. Picture a cozy study, books stacked haphazardly, a desk littered with sketches of metal discs, and a window overlooking a garden where his children played. Volta married Teresa Peregrini in 1794, a woman described as gentle yet resolute, who anchored him through years of relentless work. "I live for my family and my science," he wrote to a friend, a simple line that reveals the heart beneath his inventions. Volta and Teresa had 3 sons, Zannino, Flaminio, and Luigi, whose laughter filled the house. Historical records paint Volta as a doting father, often pausing experiments to tell stories or teach his boys about the stars. I imagine him in the garden, pointing to the sky, explaining how electricity might one day light the night, his voice soft but brimming with wonder. As a scientist with a family, I know that balance is fragile. There were nights I missed bedtime stories for lab deadlines, and I see Volta wrestling with the same pull. His mind on currents, his heart with his sons. At the University of Pavia, Volta was more than a professor, he was a mentor who inspired. His lecture hall, now called the Aula Volta, was a grand room with high ceilings and rows of wooden benches where students hung on his every word. Picture him there, his hair graying, gesturing animatedly as he demonstrated the Voltaic pile's hum. He had a knack for making complex ideas clear, using analogies like a river of electrons to explain current. Students adored him, not just for his brilliance, but for his kindness. One wrote, "Volta teaches as if sharing a secret with a friend." That's the mark of a true educator, someone who lights a spark in others. Volta's humility set him apart in an era of self-promotion. When Napoleon summoned him to Paris in 1801 to demonstrate the Voltaic pile, Volta didn't bask in the glory. He presented his work with quiet pride, letting the invention speak for itself. Napoleon, dazzled, made him a count and awarded him a medal, but Volta returned to Pavia, content to teach and tinker. "Fame is a fleeting spark," he once said, a reflection that resonates with me. "I've seen colleagues chase accolades, but the real reward is knowing your work matters, even if the world forgets your name." His life wasn't without struggle. The Volta family's finances were often strained, despite his noble title. Raising 3 boys and maintaining a household stretched his professor's salary thin. Health issues crept in too, chronic headaches and fatigue from years of overwork. Letters from the period show Volta grappling with self-doubt, wondering if his pile would be his only legacy. I've felt that weight, staring at a stalled experiment, questioning if I've done enough. For Volta, these moments were private, shared only with Teresa or close friends. But they make him relatable, a reminder that even giants are human. Volta's faith also shaped him. Raised Catholic, he saw science as a way to understand God's creation, not challenge it. In an era when new ideas could spark suspicion, he navigated tensions carefully, framing his work as a celebration of nature's laws. This balance, faith and reason, family and discovery, gave him strength. When I teach, I tell students about Volta's life, not just his pile, to show that science isn't separate from who we are. It's woven into our hopes, our loves, our quiet evenings at home. As Volta's life quieted, the world he helped create grew louder, yet his name began to fade, a poignant reminder of how history chooses its heroes. There's a quiet injustice in science. The pioneers who lay the foundation often fade, while others build skyscrapers on their work. I felt it years ago, rediscovering a forgotten paper by a colleague whose early equations sparked a field I now teach. That moment drove me to dig deeper into Alessandro Volta's story, to pull his name from the shadows. By the 1820s, Volta's Voltaic pile had ignited an electric revolution. But as new giants like Faraday and Tesla rose, the man who started it all slipped into obscurity. Why does history forget the spark that lit the flame? And what does Volta's fading legacy teach us about the unsung heroes who shape our world? Picture a museum in modern-day Pavia, its halls echoing with the footsteps of tourists. In a dusty corner, behind a velvet rope, sits one of Volta's original Voltaic piles. A weathered stack of zinc and silver discs, its cardboard long crumbled. A faded plaque reads, "Alessandro Volta, inventor of the battery." Visitors glance at it, snap a photo, then move on to flashier exhibits. This scene, imagined but all too real, captures Volta's fate. His invention powers the smartphones in their pockets, yet his story is a footnote, overshadowed by the dazzling discoveries that followed. The seeds of Volta's obscurity were sown in his own lifetime. By the 1810s, the Voltaic pile was no longer a novelty. It was a tool, as commonplace in labs as a beaker or a lens. Scientists like Michael Faraday, who used the pile to uncover the laws of electromagnetism, became the stars of the electric age. Faraday's lectures in London drew crowds, his experiments with coils and magnets sparking awe. Later, Nikola Tesla and Thomas Edison would dominate headlines with alternating current and light bulbs. Each leap forward was dazzling, but none would have happened without Volta's steady current. As I tell my students, no pile, no power grid. Yet history loves the spotlight, not the stage. Volta's own choices played a role. After retiring from the University of Pavia in 1819, he withdrew from public life, content to tinker in his villa and write letters to colleagues. Unlike Faraday, who thrived on public demonstrations, or Tesla with his flair for showmanship, Volta was reserved. "My work speaks for me," he wrote in 1815, a humble stance that left him vulnerable to being overlooked. "I've seen this in science. The quiet ones, who let their discoveries stand alone, often fade behind those who shout louder." A colleague of mine, whose sensor design revolutionized medical imaging, never sought fame and is barely cited today. It's not fair, but it's human. The pace of science also buried Volta's name. The 19th century was a whirlwind of electrical discovery. Ørsted's electromagnetism in 1820 led to motors. Maxwell's equations in the 1860s unlocked radio waves. Edison's incandescent bulb in 1879 lit homes. Each breakthrough was a new chapter, and Volta's pile, though foundational, felt like ancient history by the time batteries evolved into the sleek cells we know today. Journals from the 1830s rarely mentioned Volta, focusing instead on the latest gadgets. It's like the foundation of a house, essential but invisible once the walls go up. Cultural and geographic factors didn't help. Volta was Italian, working in a country overshadowed by the scientific hubs of London and Paris. While Napoleon honored him, Europe's intellectual elite often dismissed Italian science as provincial. English and German scientists, backed by wealthy patrons and prestigious societies, dominated the narrative. Volta's letters, mostly in Italian or French, were less accessible to the English-speaking world that shaped modern science's history. As a scientist, I feel a pang of frustration at this. Genius shouldn't need a passport, but borders matter. Yet Volta's legacy isn't entirely lost. His name lives in the volt, the unit of electric potential, standardized in 1881. Every time we say 12-volt battery or 220-volt outlet, we echo his contribution. But a unit isn't a story. Most people don't know the man behind the word. The boy who chased sparks in Como, the professor who outdueled Galvani, the father who dreamed of a brighter world. Volta's name is on every volt, yet his story is rarely told. I often say, my voice catching with the weight of that truth. This forgetting isn't unique to Volta. Think of Ada Lovelace, whose early computer code was ignored for decades, or Rosalind Franklin, whose DNA work was overshadowed. Science builds on the shoulders of giants, but we often neglect the ones at the base. Volta's story is a call to action, to seek out the hidden pioneers, to tell their tales before they're lost. When I stumbled on Volta's letters in a university archive, yellowed and fragile, I felt a fire to share his journey. His pile wasn't just a device, it was a vision of what humanity could achieve with a spark. That vision, though faded in history's pages, burns brightly in the world we live in today. A testament to the eternal power of a single spark. Every time I pick up my smartphone, its screen glowing with life, or watch an electric car hum down the street, I feel a quiet reverence for Alessandro Volta. His Voltaic pile, that simple stack of metal and brine from 1799, is the ancestor of every battery that powers our world. As a scientist, I've spent my career chasing sparks, but none burn brighter than Volta's legacy. A legacy that history dimmed but could never extinguish. Every spark in our world owes a debt to Volta, I tell my students, and their wide eyes remind me why his story matters. How does a man's humble invention become an eternal force, and what does it teach us about the unsung heroes who shape our future? Picture the world today, a tapestry of light and motion woven with electricity. Skyscrapers gleam with LED lights, satellites beam signals across oceans, and pacemakers pulse silently in chests, all powered by batteries that trace their lineage to Volta's pile. The lithium-ion cells in your laptop, the AA batteries in your remote, even the massive packs driving Tesla's cars are descendants of those zinc and silver discs. The Volt, named for Volta in 1881, is more than a unit of electric potential. It's a whisper of his genius, embedded in every circuit that hums around us. When you plug in a 12-volt charger or flick on a 220-volt light, you're speaking his name. To understand the Volt's significance, think of it as the push behind electricity's flow. Imagine water in a hose. The pressure driving it forward is like the voltage, urging electrons through a wire. Volta's pile was the first to harness that push reliably, turning chemical reactions into a steady current. Today, the Volt measures everything from the tiniest watch battery to the massive grids powering cities. A single AA battery delivers 1.5 volts, a car battery, 12 volts, a lightning bolt, millions. Each is a nod to Volta, whose spark lit the path to our electrified world. But Volta's impact goes beyond technology. It's a lesson in resilience. In his later years, confined to his Pavia villa, he watched the world embrace his invention while his name faded. Historical records show him writing letters to scientists, sketching improvements to his pile, even as younger minds like Faraday and Maxwell took center stage. Did he feel the sting of obscurity? Or did he find peace in knowing his fire burned on? I imagine him in his study, frail but proud, smiling as he read about new discoveries powered by his creation. The world moves forward, but the spark remains, he might have said, a quiet truth that resonates with me. As a scientist, I see Volta's story as a call to honor the forgotten. Science is a relay race, each discovery passed from one mind to the next. Volta handed us the baton, but too often we celebrate the finish line without thanking the runners who started the race. Think of the engineers designing solar panels, the researchers crafting longer-lasting batteries, the dreamers building electric planes. All stand on Volta's shoulders. When I teach, I show students a diagram of the Voltaic pile next to a modern battery, tracing the thread from 1799 to today. Their gasps remind me that stories like Volta's can inspire the next generation. Volta's legacy also challenges us to look beyond the present. His pile was flawed, leaky, short-lived, and weak compared to today's tech, but it was a vision of what could be. Every breakthrough starts with a spark, often from someone history overlooks. Who are the Voltas of today, toiling in labs or garages? Their names unknown, but their ideas poised to reshape the world. As I write this, I'm reminded of a vow I made years ago, poring over Volta's letters in a dusty archive. To tell the stories of those who light the way, to keep their sparks alive. This is why I share Volta's tale with you through the lens of obscure minds. His life, His curiosity, his battles, his quiet strength shows that science isn't just about equations. It's about human dreams that ripple across centuries. From Como's cobblestone streets to the electric hum of our cities, Volta's spark endures, eternal as the vault itself. So let's keep his story alive. Like, share, and subscribe to Obscure Minds to uncover more hidden tales of science. Join us in sparking curiosity, because the next Volta might be watching, ready to light the world.